Good evening, everyone. I'm Charu. I'm part of the Facebook team. Thank you so much for joining us this evening. This is the third webinar in a three-part series where we are hosting winners from Ethics and AI Awards from 2019. And today we have a really interesting mix. We will have two presenters from the awardees, which is the IIITB team, Professor Sridhar and Professor Shrisha Rao, as well as the IIT Jodhpur team, Professor Singh and Professor Mayankwatsa. That will be followed by a brief feedback session by Professor Melvin Jabbar, who is also the RFP winner from the APAC for the Ethics and AI Awards. And the closing remarks for today's session will be given by Preeti Sayal. She's a senior specialist at Niti Aayog, and her domain is within AI emerging tech. And I think for me, this is especially interesting because I think today we have a presentation that looks at it as AI from a more regulatory perspective, as well as a second presentation, which goes really into the building of the technology. And on the session, in the representative from NITI, some of the ideas that kind of come up in these presentations were originally thought of in the vision document, such as the AI marketplace. So in some ways, I think the webinar today kind of brings in the entire variety of stakeholders that are part of the ethics and AI discussion in the country at the moment. And without taking much more time, two bits, I think just if you have any questions, you can please put them in the chat. After both the presentations are done, I'll collate them and kind of present them to the respective speakers. And with that, we can start with the first presentation by the IIITB team, Professor Sridhar and Professor Rao.
Thank you. Thanks, Charu, for inviting us to present this. So our project is about regulatory impact assessment of the national AI marketplace, which were envisioned by Niti Aayog a couple of years back. So our team is myself and Professor Shrisha Rao at IIIT-Bangalore, who is just sitting next to my office here at the Institute. The work has also been done by two of our alumni, Prachi Damage and Sarthak Soni. I mean, we don't have to have a prelude of artificial intelligence and machine learning, and the impact that they are going to have in several domains, including agriculture, healthcare, transportation, finance, and commerce. It's in fact estimated that just the AI technologies and machine learning technologies alone will contribute about 1.2% additional GDP growth per year, thus contributing to about $13 trillion. So it's a huge economic activity behind the artificial intelligence and machine learning technologies. Now the question is, for all the artificial intelligence and machine learning technologies to work, we need good curated data. Right? So without enough data, it is not possible to have an AI ML technology which can learn by itself and then make decisions appropriately. And therefore, it was envisioned, not only in India, but also in some other countries, that an AI marketplace can facilitate the development of such curated data sets which can be distributed. Right? So such an AI marketplace was facilitate the matching of the data set produced typically by the crowd, right? Typically by the crowd, because we have seen instances where it's not possible to produce data sets only by certain firms or certain governments, right? Even states are not able to produce data sets which are AI hungry, right? Which can facilitate AI applications. So therefore, we need large amount of data, curated data set, and therefore it is envisioned that possibly crowdsourcing might be a way to go. Right? Now, it democratizes the availability of curated, annotated content to the marketplace, but the marketplace has to be sustainable in nature. It cannot be, it cannot just come and go, right? It has to be sustainable over a long period, and therefore, we have started looking at the AI marketplace and the functioning of such AI marketplaces. Now, there are two kinds of markets. One is the demand-driven marketplace. I will take the pointer option so that one is supply-driven and the other one is demand-driven. Right? For example, the demand-driven marketplaces include Amazon Mechanical Turk, things like that, where the customers demand certain things and the automation does that, or the crowdsourced manpower or human power do that. Right? That's a demand-driven marketplace. The other one can be supply-driven marketplace, wherein artifacts and skills are available from the crowd at large, and there are these consumers who can pick and choose whatever they want. right? So in general, we are in this particular work, we are looking at the supply-driven marketplace. Now, the schematics of the national IA marketplace was actually envisioned by Niti Aayog. Priti is there from Niti Aayog about a couple of years back, right? 2018, there was a strategy paper in AI, which basically envisioned such a marketplace. Now, this marketplace will have content creators, and we'll also have content annotators, model builders, and content tutors who interact with each other. So in general, a marketplace will have a stack like this, a curated content, above that labels and categorization of the different content and annotations and that. And then these particular data is typically crowdsourced. And then there are model builders and application builders who will use these technologies in order to build applications and models, right? So this particular set is normally for the set of consumers who build applications, models over the data which is produced by the crowd, right? So this is one of the visions of the AI marketplace, and we'll go into some of the details of how we can characterize such an AI marketplace and also, predict its function. So now there are again typically the crowdsourced systems have some problem. They suffer from poor quality. They are not monitored properly, right? Because it's a crowdsourced marketplace, and anybody can put in an artifact, and it may not pass through the quality standards, right? And it may not be useful at all. And such a marketplace will die after some time. And therefore, we need some kind of a regulation in the marketplace so that good quality artifacts thrive and the market is sustainable in the long run. Now, there are two kinds of regulations which can take place. One is self-regulating marketplace. There are economic theories abound with respect to self-regulated marketplace. Basically provides incentives for creation of good quality artifacts, right? Then there are reputation systems, which basically build a good trust between the producers and the consumers so that the quality of the artifacts on the average increase over a period of time, and the reputation of the system builds over a period of time. And the reputed producers and consumers stay in the marketplace, unreputed ones fall off, right? That's the basic theory, the economic theories behind such a marketplace. The other one is you can always regulate the marketplace using a regulator, right? So for example, guidelines such as privacy, data protection, trustworthiness, all those things have been put in place or are still evolving, I mean, at least through the EU directives. And these regulators can come in and check the behavior of the marketplace, right, accordingly. So these are the two ways by which an AI marketplace can function. A crowdsourced AI marketplace can function effectively. So the research problem that we're trying to address is how does this crowdsourced marketplace work? I mean, it is normally an oligopoly market because here, I mean, normally in a market, you will see few producers and many consumers, right? So that's an oligopoly market. But here, the producers are many in number and the consumers are few, right? And because the producers are basically the crowd. And therefore, it is the flip of the typical oligopoly market that we will see in economics. So it's normally called as oligopoly marketplace, right? Where the producers are large in number and consumers are few in number. Now, the other thing is how can we make such a marketplace work in a fair and transparent manner, and that it is sustainable over the long run. And then the other research problem, the other one is what would be the mechanisms for having high quality artifacts. Only when high quality artifacts are present in the marketplace that it is sustainable in the future, right? So these are the research problems at hand that we are trying to solve. Now, we specifically look at regulation because the regulation, the types of regulation, as we have mentioned before, can be just self-regulation, that is no regulator in place, market corrects by itself, and it's normally ruled as self-regulation. Or there can be a regulator who can be passive or active, right? A passive regulator is one who basically monitors and flags. We have seen certain instances. For example, in India, telecom is one of the areas in which the regulatory authority basically flags certain, service providers. They basically puts out performance reports so that people can see and then, which service provider is good and so on. So it's basically a passive type of regulation. In general, passive regulation is in place during the initial stages of the innovation life cycle because you don't want to put too much of regulation to curb innovation. Then there is active regulation in which the regulator not only monitors and flags, but also penalizes the culprits, right, who don't adhere to certain standards. The standard that we seek to see here is the minimum quality standard, MCQ. So MCQ is a very standard phenomena by which the regulators assess the quality of the artifacts that are there in the marketplace and then decide, whether to punish the offender or penalize the offender or flag the offender and so on, right? So these are the different types of regulation that we try to simulate, model and simulate. So in general, a pictorial representation of the marketplace is given here. There are producer agents who are many in number. There are consumers who are few in number. And therefore, this is an oligopsony market. This is an oligopsony market. And then you have, the producers produce these data sets, and then the consumers consume them based upon certain criteria, right? Then the producer self-learning, right? Self-learning producers, which mean that if they find that a regulator flags it, or if they think that the consumers have not viewed their artifacts properly, then they can correct it, right? They can increase the quality of the artifacts over a period of time. There is also a rating or feedback system. Reputation system in such a marketplace has been analyzed thoroughly by economists, right? So rating is one way by which you can build trust between the producers and the consumers, right? We have seen ratings in almost all the digital marketplaces, such as Amazon or Google, whatever it is, right? And therefore, we introduce a rating feedback mechanism from the consumers to producers based upon the artifacts, the quality of the artifacts consumed, so that it gives a signal to the producers to improve the quality of the artifacts if they fall below certain level, right? So what are the modeling interactions? We basically use agent-based modeling, and Professor Shrisha Rao is an expert on agent-based modeling. So we have two types of agents, consumers and producers here. So consumers agents have certain characteristics. The consumers can be either price sensitive or quality sensitive. We have seen in real world examples that there are certain consumers who are price conscious. There are certain consumers who are quality conscious, or both, or a mix of both. Or they can also be reputation of the producer conscious, right? Which means that they're sensitive to reputation of the producers. So even if the producer produces a high price or low quality artifact, because of the loyalty towards these producers, they will consume the artifacts produced by that producer, right? So we have these characteristics. The consumers can also have certain tolerance level towards quality. Some are very intolerant, right? Even if they get one artifact which does not match the quality requirements, then they will just penalize, giving a poor rating to the corresponding producer. Some are delayed tolerance. They have tolerance, and therefore they can accept some deviation, quality with some deviations as acceptable level. And we also have some loyalty of the consumers to producers, which will again determine whether they are reputation conscious or not. Now, on the other hand, the producers as agents, they produce artifacts in which they indicate the price offered and the quality offered of the particular artifact. And these have to be matched with the price and quality expectation of the consumers so that they can be consumed in the marketplace. So there is a matching, right? So there is an interaction between the producers and the consumers based upon the price and quality of the artifacts that are there in the marketplace. So there is also rating. There is also rating, which is given by the consumers after they consume the artifacts, whether they are up to their expectation or not. And this rating is received by the producers to learn. So these interactions between producers and consumers in the agent-based model are given here. Basically, consumers have a valuation function, which is based upon price, quality, and the reputation. And it also depends upon the flagging if the regulator is present. So if the regulator flags a particular producer, then the valuation of the consumers of the artifacts produced by that particular specific producer will vary. Then there is the reputation of the producers. We use Bayesian rating, which is mainly used in Amazon and other online e-commerce sites to give reputation for the producer based upon the artifacts that are produced and consumed. Then there are a lot of parameters that we measure, sales revenue, market share, and things like that. There is also a loyalty of the consumers depending upon the number of artifacts that a consumer consumes from a producer. They can possibly develop loyalty over a period of time. So these are the basic building blocks of the agent-based model. So I won't go into the details of this. Basically, you have producers, we have consumers, these are agents, and there is also a regulator. And the regulator can be, can be no regulator, in which case it is self-regulation. The regulator can also be passive or active, as the case may be. Right? So, and the regulator, the important goal of the regulator is to set the minimum quality standard or threshold quality for the marketplace to survive. Right? And if, for example, the minimum quality standard is not met, then the regulator can flag that particular specific producer. Right? And similarly, the consumers consume their artifacts based upon the quality and the price which is available. And then based upon that, they can also give rating, right? So they can give the rating, and this rating is used by the consumers, by the producers, in order to learn and improve the quality of the artifacts. So this is the way in which the interaction between producers and the consumers will happen in a regulated marketplace. So we'll discuss some of the simulation results. So first, we consider the base case. Base case is one in which there is no regulation, it is self-regulation. So the producers and the consumers just buy it as is produced in the marketplace. And producers are passive in nature, right? So which means that these producers are not taking the rating seriously and improve the quality of the artifacts. This is the very basic case. Now, in the basic case, you can see that the reputation of the producers over a period of time stabilizes. Right? The high reputation producers always produce high quality artifacts, and the low ones always produce low quality artifacts because there's no incentive for them to actually improve their quality, and there is no regulation as such, and therefore they continue to produce low quality artifacts. Right? Even though the average quality of the artifacts in the marketplace are expected to increase because of this huge number of high quality artifacts produced by high quality producers. Right? These producers are there in the marketplace, but none is kicked off. For example, even these low producing consumers will produce. It is possible that the consumers might not buy it. And that is one of the reasons why you see that only the high quality artifacts are being picked up by the consumers, and the average quality of the artifacts in the marketplace also improves considerably. Right? So in general, the reputation of the producers, if you see here, reputation, the high reputation continues to stay high, low reputation continues to stay low, because there is no incentive for the producers to improve their reputation score. Right? So, but it is not bad. This is not bad, as is indicated by the gradual increase in the average quality of the artifacts. It is self-regulating, no regulator is in place, administrative control is not there, and this is one of the ways by which the market can function. Now, if you introduce a regulation, what happens, right? So, as I discussed before, you have passive and active regulation, in which you basically, the regulator, sets a minimum quality threshold. And if the condition is not met, then he monitors and flags the corresponding producers and the artifacts that are produced by them. Now, you see here that the average quality of the artifacts first increases, and then it starts decreasing, and then actually decreases quite a bit as the regulator increases the threshold. Right? So the average quality of the data set actually decreases with increase in the minimum quality standard set by the regulator. Right? Now, you can ask this question, why does it happen? It happens because the minimum quality standard is so high that most of the producers are not able to produce according to that minimum quality standard, and they start dropping out, right? Or even if they produce, then their production will not meet the minimum quality standards, and therefore they'll be penalized again and again by the regulator. And therefore you see that the market actually does not function very effectively, much like in the case of a self-regulated case, right? It happens up to a certain extent, but after that, the quality of the artifacts start decreasing, right? So this is one of the things that we have learned. And there are, I'll finish it in about 2-3 minutes. There are important policy implications, right? In a crowdsourced AI marketplace such as this, ratings given by the consumers is vital, because ratings are taken seriously by the producers in improving the quality of the artifacts. And we have seen that, the average quality of the data sets in the AI marketplace actually increases, right? The presence of the regulator, it is required, right? Because the self-regulated, it has been found out by many researchers that in the AI marketplace, this self-regulation most of the times after it matures does not work, right? Because there are people who basically it's called as a free rider problem, right? So therefore, they continue to be there producing low quality artifacts and so on. So presence of the regulator will definitely help in improving the average quality of the artifacts to an extent, right? To an extent. So when the regulator becomes very strict and increases the minimum quality of standard beyond a threshold, then this particular minimum quality of standard acts as a binding constraint, and therefore most of the producers will not be able to produce quality artifacts, right? They tend to drop out, or their artifacts will just be there in the marketplace, and they will never be picked up by the consumers, right? So producers are not able to increase the quality of the artifacts beyond a certain level, right? So in effect, average quality actually falls in the marketplace, and therefore the important policy prescriptions that we need we give is that we need to have a regulation to avoid the pitfalls of an imperfect market. This is an imperfect market because it's not a competitive market. It's an oligopsony market where the producers are large in number and consumers are small in number. There is a bargaining power with the consumer because they are very small in number, and therefore it's an imperfect market. And therefore any imperfect market has to be regulated to some extent, right? And it also improves certain transparency and fairness because the reputation mechanism, as we have envisioned here, acts as a trust between, for example, the producers and the consumers. And it is also important to avoid deviant behavior of the producers, right? So, but using a light touch approach and not a very strict command and control approach, monitor vigilantly and then indicate if the market is not working properly, the artifacts are not of minimum quality standards, then it is quite possible that the producers will learn and then improve the quality of the artifacts. So the minimum quality standard should not be very high. It should be such that the marketplace will self-sustain and self-correct by itself. Right? So that's the policy prescriptions that we have. Now there are, of course, the limitations today. I'll just finish it up in 2 minutes, Charu. It does not take into account a lot of things. For example, the network effects, right? Rochett and Chirol, who are the Nobel Prize winners, economics Nobel Prize winners last year, have done extensive work on cross-site network effects, which need to be brought into the marketplace. It does not take into account the bargain power of consumers. Now, does the ABM portrays reality? We need to test it. We don't have a working, AI marketplace. Once it comes into picture, then we can actually verify our model in simulation with the actual empirical analysis. Now, this is a very comprehensive ethical guidelines which have been proposed by EU. Now, what we have touched is just the tip of the iceberg. We have touched trustworthiness and legal issues, and in specifically, we have just addressed the explicable, transparent, accountable, traceable, contestable marketplace, right? But there are other things like privacy, non-discrimination, and things like that which need to be taken account into our modeling. So, but this gives a starting point for the regulators to regulate such a marketplace. It's a very new and evolving phenomenon, and therefore we see that such a marketplace will become common in the years to come, right? So we acknowledge Facebook for awarding to IIIT-Bangalore the research grant for this project. So the challenge before us to harvest positive use cases and mitigate the malicious effects for better life for all of us. So these are references. In fact, the paper that we have written is under review in a particular journal. So that's about it from me, Charu, and then I will take questions at the end.
Thank you so much, Professor Sridhar, and fascinating. Anybody who has questions, please do put them in the chat. We will take them together at the end after Professor Singh's presentation. And I'll hand it over to Professor Richard Singh now.
Thank you, Charu. Good afternoon, everyone. And thank you very much for, thanks a lot to Facebook and Charu for organizing this webinar. And I'm really glad to be here today and share my research with all of you. This is research on mitigating bias in face recognition for vast regional diversity in India. This is a joint work with my collaborator, Professor Mayank from IIT Jodhpur. And the student contributors in this project are Shruti, Mani, Pushpita, and Surbhi. All four are PhD students in my lab. So from the title, you may realize that this is about building trusted AI systems today, right? There's a lot of discussion that is going on towards building trusted AI systems, and it is the need of the hour. Given the scope of AI today, given all the places where AI is being applied, from agriculture, finance, you heard just economics and finance, you heard from Professor Sridhar, marketplace regulations, face recognition systems, vision, natural languages, medicine, all of those places, justice, education, all of those places AI is being applied, right? So you need, everybody needs trusted AI systems on whom we can trust, right? And when we talk about trusted AI systems, the different components of that: explainability, it should be fair, it should be robust to attacks, it should be secure, it should be privacy friendly, decent, lineage, transparency. There are several of these characteristics that are there that should be there along with it being accurate, right? So accuracy is one, performance metric is one of the criterias, along with some of the ones that I just alluded to very briefly, right? So this one is more about bias. So let's do a small experiment to understand what is bias. And to do that experiment, please open your laptop, please open internet on Chrome or something on that, go to google.co.in and search wedding. I'll give you 10 seconds, 20 seconds. Can somebody tell me what do you find? Any responses?
Primarily, sorry, do you want to go, Charu?
No, go.
I see primarily Caucasian weddings.
Exactly. That is where I was going. This is what I find, right? This is what I find. See, I'm sitting in India. Many of us are sitting in India. What do you expect when you search for wedding? What do you have in mind? Something like this?
You have to proceed it with Indian wedding.
So to do this, you have to try Indian wedding, right? So this is a kind of bias, not bias in face recognition, but bias in search engine, right? So this is what we are alluding to. And when we come to face recognition, this is what we find, right? There are a lot of face recognition engines that give very high accuracy, but when we come to deploy them in India, when we talk about deploying them on diverse population, like the one that we have in the Indian subcontinent, we have a lot of different diversity. We have Sikhs, we have people from South India, we have people from North, Northeast, Western states. There are a lot of different diversity that pans out, right? And if we deploy a system of face recognition, if we deploy a face recognition system, it should give similar results for all different kinds of population, for all different kinds of subgroups, right? And those subgroups could be according to ethnicity, could be according to age, could be according to gender, all different kinds of subgroups. It should give similar results, right? Now, here is a simple example of face recognition that we observed. And this was a big motivator for me to work on face recognition systems, bias in face recognition systems. The left image on the first image, probe image that you see, this is from, this is one of my older colleagues from IIIT Delhi. His name is Dr. Pritesh Sethi. And when we gave his image as a query to a face recognition engine with just 10 images in the data set. See, 10 images with 10 subjects in the data set, it should be a no-brainer. Face recognition system would give very good results. And these are all frontal images that we're talking about. There's no disguise, there's no blur, resolution, any of those problems, right? And the system could not recognize the best match, right? The match that we are getting is best match, we are getting it as the second image. So first image is somebody else's image. My mouse is not working for some reason, but the first image is somebody else's, the second image is the best match, right? And again, the third match is obviously somebody else. Similar case you find in the next row also. We did not find the correct result in the top 3 matches. So this is the state of, this is where we started when we started this project. This was a state of art for face recognition in the Indian subcontinent. And this is what we wanted to resolve, right? So in order to solve this, what are the 2 things that we can do? 2 things are, one is we have to estimate bias. We need to know when the system is biased, right? So that is about bias estimation. And the second thing is, once we have estimated bias, and let's say we know that there is bias in the system, we need to be able to mitigate it, right? So bias could be there in 2 different things. Bias could be in the data set, which is a very common reason today that AI engines or face recognition engines are biased, because the way we are training a lot of AI algorithms are according to convenience. We sample the data set from the web, and whatever is more easily available, we take that, because we're talking about large scale data sets, right? We are using millions and millions of images to train our algorithms. And if we do that, then it's difficult to very strategically and statistically collect that data with all kinds of variabilities and diversities encoded. So oftentimes we go for a convenient sampling. And when we do that, there is bias in the data set. And then there could be bias in the decision, which could be because of the bias embedded in the algorithm at some stage, right? So the first contribution of this project was we created a bias estimation algorithm. So to do that, one of the things we did was you could estimate bias from the database from the attributes, right? You can check, let's say if you're talking about face recognition. In face recognition, you could have these subgroups identified, gender, age, ethnicity. These are the three subgroups, let's say, that I mentioned, top of my head. On this, you could see whether all of these diversities are included in the data set or not. So you could check that. The only thing that you need to know is what are the different attributes of your data set, of your problem statement, right? So these protected attributes, you should be able to compute and check whether the data set is biased according to these or not. So essentially, your data set should have representative samples from all different protected subgroups that are there, right? And once you have that, you could have different measures to report the performance. Now, some of the existing measures that are around are generally accuracy. Different measures of accuracy or classification performance are used to report the performance, like false positive rate, false negative rate, consistency, confidence, right? So these are some of the measures of accuracy. But specifically to measure bias, there are two very specific measures that are popularly used in the community. It's called as degree of bias and statistical parity. Now, generally, the way we use three different metrics: accuracy, degree of bias, statistical parity, or two of these, statistical parity and accuracy, to report. Now, the trouble with these is it can happen when you're reporting accuracy, it can happen that overall accuracy is 80% and statistical parity is very high. So one of the metrics will just tell you the overall performance. The other metric will just tell you whether there is bias or not. But in order to measure whether the algorithm is good and it is biased, I would ideally like to have a single metric so that I can see the confluence of each of these individual metrics in a single metric. So to do that, we proposed something called as precise subgroup equivalence. This is a combined metric which measures not only bias, but it also measures the overall performance. And this PSE gave us an overall metric for evaluating the performance of face recognition algorithms. The details of that, you see the primary formula included on the slide here, and the details of that are published in the specific paper. And when we evaluated this, we found that the single metric, the single combined metric, is able to give an overall view of accuracy and bias. So depending on the values of this PSE, you can tell whether the system is biased or not, how's the accuracy and how's the performance. The second second contribution of this research, this specific project, was related to bias mitigation, which my colleague, Professor Mayank will talk about. Over to you, Mayank.
Thank you, Richard. When we talk about bias mitigation, there are at three levels where actually we can explore how to mitigate the bias. One is at the data level. Once we see the data that is coming to us for training or for training the model or creating the new ML system and the AI system for face recognition, we can look at it and say, hey, you know, this data is biased. This data is unbalanced with respect to a particular subgroup. We can use some pre-processing techniques, some generative adversarial network techniques, or some data augmentation technique to balance it, right? So that's one way of addressing bias at the data level. Or we go in the field and collect more samples and come back and say, now, whatever was the unbalanced part, we have balanced it with additional data. End of the day, it's like, how can we create the balanced data set for training the model? The second one is essentially at the model level, like where the feature extractor and classification modules are biased in any ways. It can be coder-based bias, like I code in a certain style, someone else codes in some other style, and then it can be inherent bias based on my perception, right? So how we can actually look at different feature extraction and classification level biases, like at a feature, essentially at a white box level bias mitigation. This is where actually most of the researchers find it difficult, because the feature extraction level bias requires all the details of the intricacies of all the deep learning algorithms or models, which in many applications it is not pragmatic. The third level of bias mitigation is at a post-processing level. Like we have now, let's say, extracted the features or taken the decision based on the primary model. Now what else we can do, where we are not touching the primary feature extraction and classification module, and then do it at a post-processing level, like massage the features, massage the decisions, so that we take the final decision. The final outcome that we take from the system is essentially bias mitigated sample. So in this particular context, we proposed a bias mitigation algorithm in our IGCB 2020 paper, which also won the Audience Choice Award, in which what we did was we proposed a concept called diversity block for biased classes. So here the context is that we are not going to touch the classification module. We'll treat it as a pre-trained black box module. So the black box module may be biased for two classes, let's say C1 and C2, and unbiased for all other classes. Right. So now the diversity block will figure out, based on the quality as the bias assessment algorithm that we have. Now we'll figure out which of the classes are biased, and for those classes only, in this diagram, it's C1 and C2 classes. We will actually go and do the sampling and perform retraining on only those two classes. So in this particular context, if you see, we are going to jointly train the diversity block based on the joint score of C1, C2 from the pre-trained, as well as the diversity block scores. But in this context, we will not train the pre-trained black box classification model. So the classification module, the original classification module, which is good for all other classes except C1 and C2, is not touched altogether. But once we identify which subclasses are biased, we would actually retrain in a deep learning fashion, in a multitask learning fashion. We retrain these two classes, and this becomes essentially one block for us. Now, let's say after some time, once the data distribution changes, we realize that for the new kind of test sample, let's say C3 class is biased. We'll have to add only the diversity block for the third C3 class in this particular module, and then the overall module will become unbiased. Right. So this was a very neat and simple concept which utilizes the concept of joint learning in a multitask learning fashion, coupled with bias estimation. And then the results was obtained on multiple data sets. We performed experiments with different ethnicities, like a South Asian, Indian subcontinent, and white. And we performed actually different experiments with respect to whether it equal training data or skewed training data. And then what we observed was that the difference in the existing algorithms were very high, whereas for the proposed algorithm, the difference was very less. We could actually show that bias is being mitigated with respect to when we are training on first ethnicity and testing on the remaining ethnicities, and vice versa. In additional experiments on other data sets like Fairface data set and UTK data set, what we realize is that the difference between the traditional algorithm and then the bias samples were in the range of 1 to 2%. So if we had actually unbiased the model, the 1 to 2% bias results should be fixed. Right? And that's what our model did. Like if you see the difference between the traditional and the proposed one is broadly in the range of 1 to 2%. And those were the bias samples against particular subclasses or subgroups. And then we could actually mitigate the bias effect using the proposed bias mitigation algorithm. These are additional results with respect to skewed training sample. When we say skewed, it's like skewed towards either the first kind of skin color group or the second kind of skin color group. And in any case, the proposal algorithm was able to mitigate it. More details are available in the paper that you can take a look at it. But the key takeout over here is that we should be actually focusing on building fair face recognition algorithms, because that's the, so in Indian government is focusing on the inclusion part. Even Aadhaar, if you talk about it, Aadhaar is all about inclusion. So if you're going to use face recognition technology for different identity applications, then having unbiased, fair face recognition system would help in the inclusion of different identities. Our effort has been actually also in part, we are also contributing in the responsible AI for all documentation, which Niti Aayog has released early this year. The part 1 and the part 2 is under development. And then as you see here, Tom and Jerry, this is going to be a game of how to build biased and unbiased systems. And this is just a beginning. This is like, thanks to Facebook, we are just beginning like we are just warming up. This particular grant was for us to warm up to fight a long, to go for a long journey. Thank you, everyone.
Thank you, Professor Singh and Professor Vatsa. Very super interesting. We're a small group, so I think if anybody has a question, you can just raise your hand and unmute yourself. You can direct your questions to either of the panelists. They were really great presentations. I can see why everything is clear. But if we can also take questions later if people want to speak in later, and maybe I can invite the next speaker. So apologies, did not. We also, in addition to Professor Melvin, we also have Professor Xavier joining us today. So I'll request both of them if they could just introduce themselves and share their reflections of the presentation today and just how they think it kind of fits in the broader APAC and global discussions that are happening around ethics in AI.
Hi, good evening. I'm Melvin. I'm from the Philippines, and I'm joined with Dr. Ellen Javier, who is also part of the team who is doing research on AI and IoT in the Philippines, Thailand, and Japan. I have a quick question for Professor Sridhar. In one of his PowerPoint slides, he mentioned about deviant behavior, and I was wondering what this deviant behaviors are and how are these being controlled.
Yeah. So deviant. Thank you very much, sir. Deviant behavior is one where the the producers try to cheat the system, right? I mean, to cheat the system meaning that they produce artifacts which they declare as above the minimum quality standards. So the consumers consume them. Then after that, they figure it out that it is not as per the minimum quality standards, in which case they will try to reduce their rating, and but by the time the damage is already done, right? So these are all economists would say that they will just come and then read the market, they will sell all the artifacts with low quality but declare it as high quality, and then they will get out of the market, right? So this is one form of deviant behavior that could possibly happen. In our models, actually, we did not model the deviant behavior because that becomes very tricky as to, and it may not be the standard typical way by which a normal, entity would behave, right? So that is one example of a deviant.
Thank you.
So Professor Jabbar, if you could kind of just share your thoughts. Oh, sorry, and Professor Xavier. Professor Elena?
Dr. Ellen is a part of our team, and she's raising her hand. Maybe she has something to say.
Of course.
Okay, Dr. Ellen, go ahead.
Hello, good evening from the Philippines. I was very interested in Professor Sridhar's discussion on regulating the marketplace, because that happens to be a principal concern of our study participants. And these are young people, Generation Z study participants. And they point to producers as supposed to be responsible for regulations, for regulatory measures. And what's interesting, I think, is that they separated actually regulation as also part of the work of policymakers. So I wonder if by manufacturers or producers, so-called producers, include like from the perspective of the students, policymakers, government, because they said that should be also the role of this other group.
Okay, so if I understand you correctly, so you are saying that the government should also become part as producers of the marketplace. Is that what you are saying?
I'm sorry, I don't hear you very well.
No. So are you saying that government should also become an entity such as a producer in the marketplace? Is that what you are saying?
No, they meant that the regulation of the AI marketplace should also be done by government.
Oh, yeah.
That's why I was wondering whether you had two
so
there, right?
Correct. So yeah, there are in general, if you look at any governance mechanism, there is the government which makes policies, and then they leave the operational regulation to a regulator, right? So most of the cases you have the government which formulates some policy decisions, and then there is a regulator which basically addresses the operational issues of any marketplace. So in our case, yes, if the regulator is present, then the regulator will be enacted to be present to govern the marketplace. So yes, so the regulator will be part of the government, but the government dictates the policy issues with respect to the regulation. If that is, I mean, if I can answer that.
Yes, thank you. And what's interesting too in the results of our study is their perception of the role of users when it comes to users or your consumers. Their role, as according to the students, is more in terms of becoming or exercising vigilance before agreeing to using AI. Reading the terms and conditions carefully, educate themselves in the risks, and be responsible users. So that's their perception of their role in all of this, in the regulation, actually. Thank you for your interesting presentation.
Thank you.
I have another question, if it's fine.
Yes, of course.
Yeah, because face recognition is something that is not really discussed in our FGDs, and it did not. We were not able to include this in our survey. But I wonder how face recognition is pretty much popular in India, because even in Japan, which is a first world country, face recognition has not really been discussed as an issue. And even in our country, it's not an issue. But I wonder how this face recognition has become an issue in India.
It hasn't really become an issue until now, because see, Aadhaar is, there's a couple of government projects, programs that are capturing faces, but not necessarily using them at a large scale today for face recognition. But this was the issue that has been, that has got a lot of limelight, particularly in the US. If you followed recent events that happened a few months back in the US regarding usage of face recognition. So it was observed that for certain underrepresented groups, the performance, underrepresented groups in the data set particularly, may not be otherwise, the performance of face recognition is not equivalent to other groups. So there's a bias in that. There is unevenness in the performance of face recognition across different groups. So that is an issue that has been identified globally, and that is what we're working on, because India is just starting the usage of face recognition algorithms for different projects, different cases. For example, I think we are recently planning to use face recognition for digital boarding. Right. So in case for aircrafts boarding, so in that, if we plan to use digital boarding, paperless boarding in face recognition, then the performance for all different subgroups have to be at par. So that is something that we are trying to address in this project.
But at this point, is this something that is being used by the government? For example, like, when you report to offices, you have to, instead of daily time record, they use face recognition or finger.
Not specifically. For some time, fingerprint were used, but because of the pandemic, fingerprints were stopped. People had concerns with touching surfaces, right? Or multiple touching by different folks. So face recognition is being used by different institutions, maybe just for attendance of students, so that it is easier. That is happening globally, even in India in some places, but not be happening for some. I'm not fully aware of at what scale it is being used for attendance and all, but yes, some places it is happening. It is being used in offices and controlled environment on smaller groups of people. I mean, let's say 500 people in the office or a couple of hundred people in the office are there, then face recognition is being used to ease out attendance in the class.
Interesting. Thank you. Thank you.
We also have Sunil's hand raised.
Dr. Singh, I wanted to ask about your paper. What would the classes be in the Indian context? Because in a country like America, races are clearly the classes. But if Aadhaar has to become inclusive for the whole country, are we talking state-wise classes or caste-wise classes? How exactly will we arrive at the universe of classes for a project like Aadhaar?
Right. So classes are not actually these classes are not these subgroup. So what you are referring to, races or anything. So even in US, classes are individuals. So face recognition system is set up in two different categories. It's either you identify who the person is. So in that case, classes are individual. Let's say there are 100 people enrolled in the system and you want to use it for class attendance. There are 100 students. So classes would be those 100 students. And you want to predict who this person is. Like in ATM settings, right? You insert your PIN card and you want the system to identify who are you, right? Or in surveillance settings, right? The second is verification, in which it is either genuine or imposter. So you in your ATM settings, you enter your ATM card. There's an account number that is embedded in the ATM card, and you just give your fingerprint. What is happening is your fingerprint is being matched to the fingerprint that is stored corresponding to your account. So it's a one-to-one match, and the classes are only whether it is a correct match, whether it is an incorrect match. So it's just two classes. What I am talking about is these actually come as groups. These are not quantified anywhere. This is just diversity in the data set. So how many male are there? How many female are there? How many transgender are there? It's not really coded anywhere, but these are the diversities that we have. How many elderly are there? How many adults are there? How many kids are there? These are not classes. These are just subgroups in the data set. So the question that you have asked, going back to that question, just changing the word classes to groups, it's actually very difficult to quantify that as to what will be those subgroups, because in face we can still intuitively see what it will be. But if you take a problem like object recognition, there is a bias there as well. The wedding problem that I referred to, what will be the biases? Will the subgroups be country-wise, or should it be caste-wise, religion-wise? Where should it be? So just quantifying those different subgroups is a problem in itself today. Face becomes a bit more intuitive for us, but otherwise it's a very important question which we fully don't have answer to. It depends on the problem statement.
Thank you, Doctor.
So if no other questions, Professor Jabbar, if there's anything that you'd like to add, anything that you like to share about your own research?
We would like to talk about our research, but unfortunately our focus is really different from what has been presented today. But what I find interesting is that face recognition and finger recognition, print recognition is something that was not really talked about when we had our FGDs in Thailand, Philippines, and even in Japan, which is a first world country, but even those issues were not actually surfaced during our interviews. But it's interesting that in India, this is something that has been talked about, and yeah, because our topic is far from our discussion tonight, and my apologies if we're not able to really provide some substantial input for our discussion tonight, since our focus is really about ethics on IoT and AI.
Sure. I was, I think, just asking if you had many broader reflections on what was presented today. But I think interesting to note that there are, I think, different strands of the research are kind of presenting new things for everyone. With that, I think I'll hand it over to Preeti from Niti Aayog to kind of just share her views on just what was presented and how Niti is kind of thinking about responsible AI and governance.
Thank you so much, Charu, and thank you, Professor Sridhar, Professor Singh, and Professor Vatsa for your amazing research, because it's very relevant and very important. Like Professor Sridhar kind of mentioned, Niti Aayog has been trying to drive the agenda around national strategy for AI since quite a few years now. But the field in itself has been evolving so fast, and especially with the pandemic, there have been so many changes that we've seen come our way that in some of the scenarios, we were actually blindsided, we were not prepared. So you always have to stay on top of what is going on in this sector, especially specific applications of AI. Like, for example, Dr. Singh talked about face recognition, and very recently we've been doing this pilot with National Authority for Airports around face recognition for, allowing people to be able to board without having to do all those touch ways of exchanging their tickets and all of that. So we're trying to do away with that. Of course, trying to build an indigenous technology within India, which hopefully takes care of the biases, but then the axis of unfairness, like Dr. Richard correctly talked about, continue to exist, right? And if there is always this dilemma of, do you define those axes or do you not define those axes? Because defining them by itself is kind of introducing those biases into the system. So like, I think there was a question from Sunil about how the axis of unfairness in the West has these 4 elements of race, finance, and gender and orientation, and in general ability, disability or ability in general. And if you translate that to the canvas of India, what does that actually mean? Although that from a regulator perspective, I think it's very important for us to be cognizant of what does that mean when it's translated to our ecosystem. It also we have to also keep in mind, are we hindering or are we trying to be over-regulating the innovation ecosystem? You cannot hold people back. So I think constantly we are also trying to maintain that balance, and we are thinking in terms of how does ethics, how does diversity in general play out in the entire ecosystem of artificial intelligence. And people like Professor Sridhar, Dr. Singh, and Dr. Vatsa, all of them kind of help us stay on track. And that is the reason why conversations like these are really important, not just for us as country, but I think globally, because the more connected we are becoming, virtually, the more challenges of these, the lines are beginning to blur for us to define what does the entire axis of model distortion mean. Although like the example that Dr. Singh gave was kind of very important, like you have to use the right keywords and then you'll be able to search, but how many of us do actually step back and try to define it for ourselves? What does this mean for me? What does this mean for me 10 years from now? How informed is the citizen? Who is speaking for them? All of that is very important when you're trying to play the role of a regulator or a policymaker. But even more important than that are these researchers that actually tell us way ahead of time that this is what is going to happen. And all of this leads our work, directs us, gives us a lot of direction. And the Responsible AI series in itself we are coming up, actually, maybe it must be online already. We are posting the paper today, which helps you operationalize the principles that were identified in the first part of the paper, where we were trying to tell you that all of this should be driven by principles grounded in the Constitution. And on paper, all of this sounds fancy, but the moment you try to translate it into action and operationalize it and roll it out, it becomes very difficult. And the job of these researchers, I cannot even begin to imagine how difficult that is, to be able to do that for 1.3 billion people. It's not easy. I mean, you categorize people into these buckets. It's not easy to drive a model behind that. When we are putting these operationalization artifacts or frameworks in the paper that we're talking about, we do say specifically that it is eventually, at the end of the day, the developer has to be cognizant of how to stitch all of these principles in their design, how to be cognizant of data collection in itself, how to be cognizant of how you are labeling these data, all of that. So there is an entire framework that we discuss in this paper. I would highly recommend you guys take a look. Let us know what you do not like about it, because I think liking is probably the easier part. And the conversation by itself, we also emphasize in the paper that the conversation, this is just the start of it. We have to keep talking about this, because the more aware we are as people, the more driven these solutions will be in a direction which is less biased. I cannot say like bias will be totally eliminated, and I cannot really, I'll be unfair if I say that, but at least we can try to get to a world where the biases, at least in the virtual world, do not exist as much as possible. So yeah, that's the final hope we have with these papers and these research in general. Thank you, Charu and Sunil, for having me here. It was really amazing to get updated with all the research going on. I'll probably sync up offline with everyone else. Thank you.
Thank you so much for joining us today, and also to all the presenters today. I know many years of work has kind of gone into this. The awards were given in 2019 in a very physical environment. I remember meeting everybody on this call. But with that, thank you so much for kind of closing it very well, but I think also kind of realizing that as much as we work towards some of these objectives, and I think both the presenters also alluded in some ways, it's a moving target. As much as we develop, we kind of discover what is missing in these systems. With that, thank you everyone, and thank you Professor Jabbar and Professor Elena. I realize this is very late for you, so thank you so much for joining us. And for everyone else, in short time, I think a lot of the research most of the research that's kind of come out of the 2019 awards is in the process of publishing. If you're interested in kind of getting more detailed papers, please do let me know. Happy to liaise with the researchers to make sure that you have the information that you need. Many of these researchers did publish their early findings as part of the India AI. So if you are interested, please look it up on the website. Early summaries are available at the India AI portal. And thank you so much. And with this webinar, we also kind of end our 3-part series. Have a nice evening, everyone.
Thank you.
Thank you. Thank you. Thanks, everyone, for joining.